Our second example here is what a motion problem would look like with a table. It's from the 2015 exam. It's question number 3. There is no calculator allowed on this one. And what I have to work with is a table of velocity values. So Joanna is jogging, and her velocity at certain times is given in this table. And I'm first asked to estimate v prime of 16, and this is v. So I'm asked to approximate the derivative of v at 16. So this is where I find where 16 would fall, and it would fall in between the 12 and the 20. So I'm going to work on this interval right here, and I'm going to use an average rate of change to approximate this instantaneous rate of change. This is actually no more than y2 minus y1 over x2 minus x1, which is slope. I don't actually have to simplify this, but if you did, you would get an answer of 5. The question doesn't say anything about giving units, so I don't have to give units. If you chose to give units, the 240 and the 200, their units are meters per minute, and the 12 and the 20, their units are minutes, which ends up being meters per minute squared, which is an acceleration unit. And I know when I do v prime, I'm finding acceleration, so everything just matches up. In part B, I'm asked to explain the meaning of this integral in the context of the problem. So when it says in the context of the problem, what you don't want to say is just, oh, I'm doing an integral from 0 to 40 of absolute value. You want to say what it means as Joanna is jogging along the straight path. You should recognize the absolute value of velocity is an integrand as being your total distance traveled. So I would say that this is going to represent the total distance that Joanna has jogged. This is also asking me to use correct units. So here's my total explanation. It's the total distance Joanna jogs in meters, so that is the units part, from t equals 0 minutes to t equals 40 minutes. Whenever you explain an integral, you have to include 3 things. Number 1, what it is, that's the total distance. Number 2, the units, that's the meters part. And then number 3, you have to say what the limits mean in the context of the problem, and that is just her time interval. I'm also asked to evaluate that total distance traveled using a right Riemann sum with 4 subintervals that are indicated in the table. So 0 to 12 is 1, 12 to 20 is 2, 20 to 24 is 3, and 24 to 40 is 4. I'm going to make sure I pull up these numbers on the right side. And also, because it's absolute value, I need to make sure that I take this negative 220, and I'm going to take it as a positive 220 when I do my right Riemann sum. This is my right Riemann sum here. Notice that that 220 is a positive right here. You don't have to actually simplify this if you don't want to, especially since you don't have a calculator. If that's your thing and you're good at it, you can bring it down to a 7600. But I would advise to just stop it right here. In part C, we have Bob, who's riding his bicycle. We are given Bob's velocity as this equation, and we're asked to find Bob's acceleration at t equals 5. We know that acceleration is the derivative of velocity, so I'm going to start by finding the derivative of b. Make sure to write your b prime of t equation first, and then we're just going to substitute a 5 into it. Here is my b prime of 5. I can calculate if I want to, but you don't actually have to. You could leave this b prime of 5 like this. It is an acceleration, so I put an acceleration unit on that. There's nothing in the problem that's asking me to find the units, so that actually, I don't need to write it, but it's good to know that's what an acceleration unit looks like. In part D, I'm asked to find Bob's average velocity. And again, just think of that as saying average value of velocity. So we're going to start by taking an average value integral. So it's 1 over b minus a times the integral from 0 to 10 of Bob's velocity, which is given up here as b of t. Without a calculator, I'm forced to do this antiderivative by hand, but it's an easy one. It's just a power rule. Once you plug those limits in, you don't actually have to calculate. You can give that as your final answer. If you did calculate that, you would end up with 350. Those first 4 parts represent a pretty standard FRQ. I've added a few extra questions at the end just so you could see different types of questions. In part E, I'm asked to find the exact value of this integral, 1 over 40 in the integral of 0 to 40 a of t dt. Because I'm given a table of velocity values to work with, I need to get this to be velocity, so the antiderivative of that acceleration is going to be velocity. Antiderivative of acceleration is velocity, and then I plug in my limits, so v of 40 minus v of 0, and now I can just go to my table and look up these values. I get 150 over 40, and that is my exact value of that integral. There's another part of the question that says explain the meaning of this integral in the context of the problem. So there's 3 parts that need to be shown in that explanation. Number 1, what it is. Number 2, the units. And number 3, what the limits mean in the context of the problem. What you should recognize when you see this, that 1 over 40 makes this an average value problem. So when you see that fraction out in front that matches the limits, this is an average value, and it's the average value of whatever you have sitting here in the integrand. So this is going to be an average acceleration. I also need to provide units on this explanation. This is acceleration, so I'm going to say in meters per minute squared. And the third component is to say what these limits mean in the context of the problem, and that is just my time interval. And I have my 3 parts. What it is, average acceleration, my units, meters per minute squared, and my limits are showing up in my explanation. The last question wants to know how many times does that velocity equal 220? I'm told this is a differentiable function which implies continuity. That's an important point for me to establish because I'm going to use the IVT, the intermediate value theorem, in this problem. Looking for where the velocity equals 220. So I move from 0 to 200. There is no guarantee that I'm going to hit the 220 in there. However, when I move from 200 to 240, because 220 is in between those numbers, I know that I have to hit a 220 on that time interval from 12 to 20, so that's 1. And again, when I move from a velocity of 240 to a negative 220, once again, I have to bypass that 220. So that's 2 times that I'm going to hit a velocity of 220. I use an inequality to represent that 220 is in between v of 12 and v of 20. Therefore, I know v of t equals 220 on that interval. And also 220 is between v of 20 and v of 24. In this region of my table. Therefore, I know I'm going to hit that 220 on that time interval from 20 to 24. And also make sure you answer the question. I want to know how many times, so I'm going to say 2 times. And that completes this problem.